Today, we'll take you through our journey of building a whole new product from ground up, which is LinkedIn's continuous deployment platform. I'm Rahul. I am the tech lead for LCD, and we have my partner, Keshav. He's a staff engineer at LinkedIn and also our Airflow expert. So today, I'll take you through this agenda. Whenever a new product needs to be built, a lot of whys need to be answered, like why are you building it? What's the ROI? Why can't you just refactor the old code? We'll go into the whys of why there was a need to build this platform. We'll talk about what is continuous deployment, what is the platform going to do, and how is it going to help LinkedIn overall. We'll talk about the architecture, we'll do a deep dive into that, and we'll talk about the use cases that it's trying to solve which the earlier platform did not solve. LinkedIn, anyone over here not familiar with LinkedIn? Good. It's always good to work for a company where you don't have to explain what it does. So just to tell you the numbers, LinkedIn has about 1 billion members. Every minute, about 13K connections are formed at LinkedIn. Every minute, 7 people are hired through LinkedIn. Every minute, 9K members apply for a job. Every minute, about 1.5 million feed updates are viewed. Every minute, about 138 hours of learning content is consumed. This is the scale we LinkedIn engineers have to operate on. This is the scale we have to work on to make our members happy. So let's get into the nitty-gritty details of deployments. What are deployments? We as engineers love to write code. We write code to deliver features. We write code to fix bugs. But just writing code and getting it merged is not important. What is important is how do you land that code, that feature into the hands of customers? That is where the real value of the feature lands in. And that's why I call deployments as the last mile in the software deployment lifecycle. Even in 2024, people deploy two ways. One is the manual deployment, where after writing code, the engineer has to go and deploy his code. Now that is a very time-consuming thing. The reason being, today, services need to be resilient. That means the service needs to run in multiple colos. As a result, the engineer is responsible for making sure his code lands in every colo. He will be responsible for validating the changes. He or she will be responsible for monitoring if the deployment is still safe. He or she will still be responsible for rolling back in case of an issue. So you see how time-consuming it is? That is the time the industry or the company is taking away from his development lifecycle. He could be writing code, but now he's busy deploying. This process is even more error-prone. You have humans involved. Humans love to bypass processes. They might stop validating things. They might just deploy code in all the colos at the same time. We have seen a lot of recent incidents where the code was deployed at the same time everywhere and nothing worked. People can also try to deploy on Friday evenings. Some of us might have seen what happens on that, right? That is the problem with manual deployments. There comes a second way of deployment, which is what we are investing in. That is continuous deployment. Continuous deployment is a process where once the code is merged, the platform takes over. The engineer is now free to go back and write code. But now the platform is going to make sure the code is safe to be rolled out. Platform will make sure the right deployment practices are being followed. It won't deploy the code in all colos at the same time. The platform will ensure the right deployment policies are enforced. It won't let you deploy on Friday evening. It will also validate the changes, and in case of issues, it will also roll back it for you. So, a lot of time, a human toil was reduced. We also followed all the processes, and we've created a standard procedure for all the teams at LinkedIn to follow it. That's what continuous deployment gives you for free. Let's look at the landscape of deployments in LinkedIn. Earlier slide, we showed you the scale that LinkedIn operates at. To keep that LinkedIn up and running all the time, LinkedIn had a lot of stateless services. It has a lot of stateful services. It has a lot of offline services. And today, everything is AI. So of course, ML models. We need to deploy also ML models. These kind of services, we want it to be deployed through one generic platform. We don't want a specialized platform for each one of service. We'll talk about the scale of deployments at LinkedIn. Any guesses like how many service LinkedIn needs to keep 1 billion members? 1,500, 5,000? You are close, 7K services. That is the number of services we have at LinkedIn, and it's still growing. Any guesses how many deployments we do in a month? 1,000, 15,000? So we had 5,000 services, 7,000 services. If we are deploying in a month 15,000 times, that's really bad for us, like 2 deployments in a month. We want to be deploying very often. So you'll get the numbers now. We are around 7K services. We have around 12K pipelines, aka DAGs in Airflow world, and we do around 1 million deployments per month. That is the scale we are going to reach. And we want to do continuous deployment, so the numbers will keep going up. So that is the scale that this platform needs to handle to keep LinkedIn.com up and running. This is a very interesting graph, and we'll spend a couple of minutes on this. This is a graph of deployment staleness. Deployment staleness is defined as how old is your version in production. If you see a staggering 45% of the services have not deployed for a month. Now, why is this a problem? First thing I talked about was the value creation. A value is delivered only when the code lands in the hands of consumers. So for a month, the value was not delivered. Second, I call it as an on-call nightmare. If you're not deploying for a month, teams are writing code for adding features or bugs. Whoever is going to deploy, good luck to him, because he's going to deploy multiple features at the same time. And if something goes wrong, as an on-call, the first thing is, hey, let's roll back, which is good. But now, you spend time on rolling back. Next step is cherry picking. Oh, which one is good, which is not? Again, this is not where engineers should be spending his time. This is because the team did not choose continuous deployment. Third is an often overlooked thing. Every company has infrastructure teams. The job of infrastructure team is to improve the productivity and the efficiency of each service. The way infrastructure teams deploys their changes is through library. That means every service has to update their library version. Now, if every service is not deploying, that means those infra changes are not getting reflected for your service. That means it's a vicious cycle. The changes that were supposed to improve your productivity of your service are not getting deployed. And now what happens is a lot of times, these infra teams, the managers of infra teams are running after every service owner. Guys, can you deploy? That is again a human toil. Time that could have been well spent on other things. But people are running after people, hey, can you guys deploy? That's the challenge with deployment staleness. That is the challenge if you don't have continuous deployment. Now, this is the final question of why. Why can't your old platform handle continuous deployment? So I told you about our new product, LCD. Any guesses what was the predecessor name? There's a hint on this. The current product is LCD. So the name was CRT, Continuous Release Tool. CRT, LCD. We are not following the TV industry, but that's how it came up to be, LCD. And it was coincidence that the earlier name was CRT. So let's get into why we had to rebuild. So when the original solution, CRT, was built, it was about 6 years ago. LinkedIn was still not at the scale as it is today. And the entire solution was built on a single service paradigm. Today, LinkedIn has to cater 1 billion users. The complexity grew. Now, today we have a lot of services which have dependency, like only if a service A is deployed, service B should be deployed. Only when B is done, do C. When C is done, do D. And the rollback needs to be in a specific order. We have services which have about hundreds of clusters. So we need to support that. So the existing solution was not able to scale to the needs. And what happened was a lot of data infra teams started building their own deployment platform. So now we had multiple deployment platforms trying to do deployments. Third thing is very interesting. It is not a technical thing. And we'll talk a little bit more about it. There was a lack of mistrust around validation tools we used at LinkedIn. Validation tools are the one which gives you a signal whether this deployment is safe to roll out or not. If services don't trust them, they will not adopt continuous deployment. So we'll talk about what we had to do to increase the trust, because without them, we were not going to be successful. And another challenge was they were a team in a different org. So that's the biggest non-technical challenge we can talk about. Third thing was, it was never designed to scale well, like adding new features, adding new validation tools, adding deployment schedulers was a painful process. It used to take a couple of quarters. And everyone had to depend on our team for the integration. So we were becoming the bottleneck. Last is the workflow schema was too verbose. Anyone who had to update their workflows for deployment pipeline had to read a lot of manuals. They had to understand deployment strategies. They had to understand validation tools terms, which was very unnecessary. And it caused a lot of toil. Even after 7 years, we used to get every week 1 or 2 on-call tickets saying, hey, my workflow does not work. So we wanted to simplify all these problems with our new solution. Before we get into the vision, we also thought about the 3 personas that we're going to deal with our LCD platform. First one was the platform admin. That is our team, which is developing and managing the platform. Second persona was our partners, the validation teams, the deployment scheduler teams, who would be writing tools on top of our platform to improve the overall deployment experience. Third, and the main one, was our users. These are the service owners, the owners of the 7,000 services at LinkedIn, who would be using our platform to do deployments. So based on these personas is how we have also designed our platform. This is the final vision that we came up with. And everything goes back to the whys. First of all, modular design. The design should be a loosely coupled architecture in a way that any component, tomorrow if we want to replace, the only persona that would be impacted is the admin persona. Neither the partners or the users should be impacted by this change. That's what our design took care of. Democratize the platform for partners. One of the gaps we had in the earlier product was any change, they had to go through us. What we did is we empowered the partners to write tools on top of our platform so that they can innovate and move faster without us being the bottleneck. That being said, we do have governance that not anyone can write any tool and break the pipeline. No-code, low-code pipelines. We talked about the complexity of the workflow earlier. What we wanted to do was make our workflow schema so simple that no one has to do a lot of things. They just need to know, hey, what do I want to deploy? Where do I want to deploy? When do I want to deploy? That's it. They don't need to understand the deployment strategies, the policies, and everything. The whole platform takes care of it. We'll talk about it more in details. We wanted a single deployment solution across LinkedIn. As you saw, we have a variety of services at LinkedIn. We don't want an engineer to rerun a tool to deploy a new service. A single deployment solution across LinkedIn was the goal. We wanted to increase continuous deployment adoption. We talked about it, why that is important. We wanted to get engineering efficiency metrics, also called as DORA, out of the box. These metrics help teams, managers, and managers of managers to make actionable decisions based on the metrics. Example, hey, the team is doing a lot of rollbacks. Maybe they don't test enough to the left. They should have more unit tests. Hey, the team is taking a lot of time to resolve incidents. That tells the product is a lot complex. Or maybe the team doesn't have a lot of seniority. Right? Those kind of decisions can be made because of these engineering efficiency metrics. We wanted to enforce best deployment practices. Don't deploy in all the colos at the same time. Don't deploy on a Friday evening. Those are the basic practices which we wanted to enforce, and not every team has to know about it. We'll enforce it. People want to change it, please change it. But that's by default are the practices. Last but not the least, reinforce the trust in the validation tools across LinkedIn. Those are our partners. And we cannot be successful without our partners being successful. So work with them to make sure people trust them. And if there are gaps, work as one team and solve them. This is a 10,000 feet view of our entire architecture. I'll go from the top to the bottom. At the top, the user personas will be interacting with UI and the CLI all the time. The UI and the CLI will interact with the mid-tier service, which is the gateway service. Now, this is the beauty of the loosely coupled architecture. Tomorrow, any component changes, very few people will be impacted. The gateway service talks with our Airflow. Airflow is the heart of our platform. That is one which executes the pipelines. What we have done is our persona partners will be writing actions Keshav will talk more about that, and those actions are the one which are executing the deployments or various steps that are involved in the deployments. They are running in a Kubernetes platform, on a Kubernetes cluster. These actions always talk to deployment policy engine. We used OPA, and it also talks to deployment transparency. That is our historic storage for all data related to deployments. The actions also talk to the deployment schedulers, the validation tools, and everything that is needed to do the deployments. This is a high-level overview of our architecture. We were lucky enough to have a UI UX team because in the infra world, it's a rarity. The UI UX team did their research. They talked to teams about the challenges of the existing UI design. Based on that, based on the user flows, they came up with mocks, and finally we have a UI which is in beta version, and still it's going good. Over here you'll see, a user will see the deployment history, who started it, when he started it, when it ended it, how long did it take. If it failed, we can click into view and understand more nitty-gritty details of why it failed. Over here, we did talk about that continuous deployment is the goal, but we do understand that there can be special scenarios where people had to do manual deployments, where on the left side you see a user would come in and say, hey, I want to do a full deployment. He would click in the details and say, hey, this is the application version, config version, and so on. If he wants to do an emergency response strategy, which you see at the bottom, hey, I want to do a rollback, I want to do a hot fix. They would click on that, and they can fill in the details. On the right side, you see, it's the policies. When you're deploying, we would point out, these are the policies you're going to violate as you deploy. You have a deprecated library version. It's a policy violation. Are you okay with deploying? You are deploying outside of scheduled window. Are you okay with all those things? Some of the policies will let override happen. Some of the policies we don't. And some of the policies need like director plus approval if they want to override. These are the ways we have done policy involvement in order to make deployment safer. From here on, I'll hand it on to Keshav.
Thank you, Rahul. So now let's take a deep dive into the architecture of our continuous deployment platform. So Rahul gave you a 10,000-foot overview. I'm going a little bit deeper. Here, we will start from the left. As a user, there will be two modes of interaction. One is while you are trying to create a pipeline, or while you are trying to run or view the pipeline or change some state. In both the cases, a user will interact with either our pipeline builder service or our UI that Rahul just showed the snippet of. Say I'm trying to create a pipeline. We provide a CLI for that initially. Our goal is to merge that experience in the UI. As Rahul said, we are in a beta phase, and we are building on it. So for now, we have a pipeline builder service, which allows user to fill up a quick form and converts that into a DAG, eventually, which will go to our Airflow clusters and then our deployment gateway service, which will then render it on the UI. From engineer will go to UI to actually go create a new pipeline run or cancel it and so on and so forth. So all that is powered by our API service called deployment gateway service. We have a deployment transparency service, which is the historical data of whatever has happened related to deployments at LinkedIn. And that is powering our UI and providing that history view. Then we have multiple Airflow clusters, which executes our pipelines and renders it, enforce policies. We will go even deeper into the Airflow architecture there in the next slide. But we also, the Airflow cluster interacts with deployment policy services, where we enforce all the policies like, hey, do not deploy on Friday evening, please. Or are you the person who's allowed to deploy in the first place or not, right? And then all the actual, execution happens inside Kubernetes cluster, where all the downstream, schedulers are talking to Airflow in order to, hey, am I done now? Or do I have to do something more? And so on and so forth. And based on that, our DAG intent defines what would be the next logical step to do. So this is like when we down into the Airflow view, this is how we have orchestrated it. So we are deploying Airflow on Kubernetes. So that gives us capability to scale up and scale down our web servers, schedulers, and workers on demand, right? We set them up as a replica set or scale sets, and we are using MySQL as the metadata database. I don't have to go into too much detail about this. Everybody, I hope, knows about how this works. So what I'm going to talk about is this aspects. We are leveraging Kubernetes pod operator to orchestrate these different actions. And these are the logical units which will go and talk to our different schedulers. Say, for example, I need to deploy an application in Colo 1. Airflow in our control plane will go talk to the API server, Kubernetes API server, and like get me a pod, and then execute that business logic and communicate with the deployment scheduler to actually go and deploy that application. We have, scheduler. By the way, we are using Airflow hooks extensively. We use pre-execute, post-execute, on-kill, DAG callbacks, all of the shebang that Airflow provides, so thank you for that. And it saved us a lot of trouble. For example, like for pre-execute, we leverage that pre-execute hooks to enforce policies. Even before somebody goes and talks to a downstream scheduler, we need to ensure that all the policies are adhered to. That is where we leverage pre-hooks. Or say, for example, once my DAG or my pipeline has completed, how do I pass on that information back to deployment transparency? That's where we use on DAG DAG callbacks. And then finally, we use on-kill. So for example, your pod can just die any time randomly. Or as a user, I can go and cancel my pipeline. So there has to be a distinction between both these events. One is a success because I, as a user, wanted to go and kill it. The other one is a disruption, and I need to handle that. So all that term handling is also happen as pre-execute, and we always ensure that no matter what, our pipeline executes as we want it to be, and it's resilient. One more thing I forgot about mentioning here. We are shipping out all our logs to Azure Data Services, and this provides us observability. Rahul talked about three personas: as platform owners, as users, and as our partners. Say, for example, as a user, I want to know what exactly happened with my pipeline. I can just go and query custos using KQL, and I can see the entire history. Our platform UI will eventually stream those logs for you, so users don't have to do it. But the advantage that we get from there is you can write your own custom alerts on that. You can say, like, hey, if I see X type of failures 10 times, give me an alert. So all that is provided by Azure Data Service to buy. And then we send notifications to Slack. In Actions ecosystem, this is the bread and butter of why we wanted to use Airflow to begin with. One of our goals was to democratize actions for our partners, like the entire ecosystem for our partners. When we started this 2 years back, one of the biggest challenges was any new feature addition that needs to happen took us about 2 or 3 quarters. And we thought about how can we simplify that. And that is where we came up with hey, if there is a world where users just write their business logic or partners just write their business logic and rest of all, we take care of it. Can that happen? And that is where we started looking into Airflow, and Kubernetes pod operator gave us the solution. Now, as a partner, you just have to write your business logic in any language given as a containerized application. We provide all the contracts and and hides down all the complexity of understanding what Airflow is for you. And then voila, you have an action. So what we did is use those small actions or containerized applications and combine them as reusable components, which then users can use. For example, one of the reusable component which uses 3 different actions is canary, EKG, and promote, which canary means of course, just deploy somewhere, then run some validation test, and then once the validation test succeeds, go promote that to the production. What this actions ecosystem also provided us is we are not enforcing people to just use any particular language. Writing a containerized app is language agnostic. I didn't know that Airflow 3 was coming with like, hey, you can write your task in any language. I wish they did it like 2 years back, but since they didn't, we found out our way around it. But if you are going to Airflow 3, maybe you can just hide that complexity with Airflow tasks. So as a user, I told you, like, let's look into the journey of how, as a user, I will interact with actions, and then as a partner, how I will interact with action. So as a user, I'll go and talk to my UI, and which in turn Airflow. And here is an example of a random pipeline, which has 2 steps, our deployment step and our validation step. What happens then next is deployment. Once Airflow starts executing it, it uses Kubernetes pod operator to kickstart a pod inside one of the colos wherever we are trying to deploy. And then as a next step, we go talk to open policy agent. Hey, can I deploy it? Is the user valid? Is there a pause? Is there a moratorium going on? And so on and so forth. Once OPA tells us, no, everything's good, we go and talk to our deployment scheduler and then pass in all the information like, hey, we have validated everything. Your only job is to just do your action, deploy the application, and until that time, our pod will just sit there and just wait for the response back. And the same thing, let's say if deployment is taking too long, we are constantly updating deployment transparency, like, hey, 30% done. Say you have an application or a cluster which has thousands of applications, right? Or thousands of instances underneath it. You are done with 40 out of those, we will just reflect it instantaneously. And once the deployment action finishes, control goes back to Airflow, which then kickstarts the next step, and the same process follows again. So this is how, as a user, I interact with actions. Now, as a partner, how will I do that? So as a partner, say I am an iOS developer and I need to write my own custom logic to deploy my iOS app. What we do is we provide a custom library or a template. It's a GitHub repo with some things stubbed out where we provide like what inputs you'll get or how you'll get it. We are using environment variables for that and like how you will have to send the information back. So user comes, use this template, create a fork, writes this business logic, pushes it to GitHub, and then eventually our build process happens and an image is created for that particular action, and which, when we are creating a new pod, will be pulled by Kubernetes at the runtime. Moving on. So another thing was like, hey, when you are building a new feature, I am like taking the same example as in the previous slide. I'm an iOS owner. I just don't want to wait for you to go and deploy your ecosystem. How can we short circuit all of that and like quickly deploy if I know I'm an iOS owner and I can deploy my new feature and like provide it to all my users? So variables came to rescue. What we use is we allow our partners to go and update a particular variable through which at runtime when we were building the pod spec, we check and say, hey, okay, this is the latest version that needs to go in. And since that moment, all the next deployment that will happen will use the latest version of their actions image. Saves us a lot of trouble and time. Another thing is how we are rolling out features. Like we wanted to provide our users with like zero downtime upgrades. What we do is like from the users testing, we provide a sandbox Kubernetes environment where we let users spin up small Airflow clusters, full-fledged clusters that they can create. And that's where they build their new features or test it. And then once the unit testing and everything is done, we go and we take those things, our build goes through a CI/CD, and then we put it in a Canary environment. This is an early integration environment where you do have some capabilities to validate things, but it's not an end-to-end testing or integration testing completely. Because in early environment, you do not have production data, you do not have availability or like connectivity between the actual deployment systems which are operating in productions in the early environment. So we do let you do some basic integration testing that we have called out. And then once this is done, what we do use is a blue-green strategy. So we always have 2 clusters as active at any given time. And what we do is we roll out the changes in one of the colos, and then slowly start migrating people from, like, say, cluster A to cluster B. That will provide us like the cushion where we are not just impacting everybody. So we slowly and surely ramp our new feature to our customers, and like it provides also like at any given point in time, there is always one cluster which is always healthy. And we can quickly roll back if we have to. And we leverage our own platform to do all of it. So we are using the same LinkedIn continuous deployment that we are building for others. One quick disclaimer here before I proceed is, like, you have seen like so many clusters, we are managing all of that, but we are not the Airflow as a platform provider at LinkedIn. We have a separate dedicated team for that, but we do not use their product. We manage our own Airflow ecosystem, but we share the same tooling and knowledge that they do and we have. So just a quick call out there. Now, as Rahul was talking about, changes needs to happen. If you're not changing, you're not growing, and soon you'll be out of the business. So, you cannot just build a feature, throw it out there, and hope, like, this is my final state. No, changes will keep on happening. That is why we all have a job. But how do we ensure that these changes are not breaking things? An example of that would be like, hey, CrowdStrike recently just deployed a version out, and we all know what happened later, right? So how can we ensure that those things never happen? And this is where the pipeline governance comes in play. We sat down, and some of our leaders internally talked about it, and they came up with a set of guidelines that every product needs to adhere with. For example, always do canary before you promote it to production. Very basic thing, but sometimes we just skip it. Or, there is so much integration testing that you can do in a pre-prod cluster. As in our own instance, we do have a canary or an early integration system, but it does not allow us to interact with all the different downstream schedulers that we have. And you sometimes have to push it to production. Then when you are doing that, it's basic thing. Do not go to all production at the same time, or have soak times between when you go from one prod to the second prod. All of these things are now baked into your pipeline, and we do not allow our end users to define it. We have taken that control away from them. But at the same time, the people can say, like, hey, why are you taking that control away? There are 2 reasons for that. The first thing is now it is uniform. We will know exactly what is happening when. The second reason is enforcing any new governance is now centralized in our platform. And it would be very easy for us to enforce it. Otherwise, as like in our previous generation, everyone had their own way of deploying stuff, and things broke. Here's a sneak peek of what it used to be. So earlier, our customers used to write a huge YAML like JSON, and they used to provide different strategies, how they want to, what they want to do in case some failure happens, how do they want to do canary. Now we have very simplified it: what, how, and where. Simple 3 questions. You answer that, and what you get is a pipeline intent. This is the actual pipeline intent, just the things are mocked out. But this is an actual intent which Airflow deploys with, right? And we convert that into an actual DAG. This is how that YAML is translated. We are using dynamic DAGs for that, and we create these beautiful DAGs with it. One of our biggest and most complicated DAG has about 882 tasks in it. And it is one of the most complicated systems that we deploy. But this is just a simple snippet of one of those things. And again, I was talking about one of the reusable components. So here, what you see as prod 2 on the left, and then inside it, there is a select canary. We select where you want to deploy first out of, say, 5 prod environments you have. And then what you see as fabric 1 will just zoom into this huge thing where, like we are doing a canary in the first place, then doing EKG, which is our validation. And once the validation passes, you actually go and promote that to production. And once everything succeeds, the control is returned back and we move on to the next steps. Rahul, over to you.
Thanks, Keshav. So this is the thing that I talked about in the earlier slides where there was a lack of trust on some of the validation tools, right? So this is an example of how non-technical problems occur and what do you have to do to move forward. So when we're onboarding early adopters to our LCD platform, continuous deployment platform, the goal was humans should not have to intervene. That means they need validation tools to ensure the quality is good. When we started onboarding early adopters, and we said, hey, we are going to enable these validation tools by default, some of the responses were like, hey, I haven't heard of this validation tool. So they were not confident about it. Those we were able to handle. We were like, okay, we'll onboard it, and if it doesn't work, let's talk about it. But there were some customers who are like, wait, we don't even trust that. And we are like, why? What happened? And they are like, oh, we used to use it, and the signals were bad. Right? And that was like a couple of years ago. And things have changed. But the trust that they had remains. Like, oh, I don't trust this thing. What we had to do was we had to build a very close partnership, our validation tools. We had to act as one team, though they were in different orgs. We had to align our roadmaps. And whenever we had a difficult customer who would say, I just don't trust them, we had to work with them to build dashboards about their predictive accuracy. We started showing like, hey, it has been 2 years. A lot of other teams are using it. And still, if they don't like it, we would pull in them in meetings, have them talk to them. What are your gaps? What problems you want to solve them? And they would help you to fix them. So it was a very close relationship. And because of them, we are able to, we are in beta phase and soon we'll be in GA. Just because of them, we are able to achieve continuous deployment at LinkedIn. So basically, just one more slide. So these are the basic validation tools that we support. Canary validation, as Keshav mentioned, was like, hey, every deployment needs to go to a few hosts. The canary validation will ensure that, hey, everything is fine. There is no exceptions, no metrics are going off and everything. And if it is, it will just roll back. So that's what canary validation. We have a test manager which runs integration test in the pre-prod clusters. We have Epsilon, which replaces the prod traffic on a set of hosts. Teams can write more tests on based of that. We have smart canaries, which does real-time detection of what's the perfect prod fabric where we should deploy right now, right? And we have a few more that are coming up. Last slide. I think these are the new use cases that we started supporting. One was schema deployment. Earlier, schemas were always deployed manually. These are like the database schemas that apps services want to deploy. There was no connection between schema deployment and app deployment or the service deployment, which resulted in a lot of incidents, like someone did not deploy the schema but started using that in the application. That caused multiple incidents. Today, it's well integrated in the platform. So we have schema deployment and then the service app deployment. We are able to support a lot of stateful services like Pinot, which had the use case where they have like broker, controller, minion, that needs to be deployed in a specific order. So we are able to support them. We can support provisioning of clusters, like it's just not deployment, but you can also start provisioning. And that's where those actions come into picture. People who want to support new use cases are writing actions, and we help them integrate with our pipelines. We are able to support scheduled deployments. One of the next few feature that we are going to support is Chaos Monkey along with the same deployment platform. And that's it.